Then we also have some solid particles which are there in atmosphere. We also have what? Some solid particles which are in atmosphere, and they are being known as particulates and aerosols. So solid and liquid particles which are there, which could be, dust, pollens, soot could be there, sand could be there, ocean salt could be there, volcanic eruption and volcanic ash could be there, meteor fragments could be there, and they would be termed as what? Some sort of solid particles in atmosphere. These solid particles in atmosphere will going to facilitate scattering of light, absorption and reflection of solar radiation. You might have seen sky, the color in sky, basically red, orange, or this color you might have seen surely with respect to the sunrise and sunset. So whenever we have a sunrise and sunset, there is a angle which has been made by the insolation with respect to the aerosols or these particulates which are there in the atmosphere. As a result of this, there will be a reddish, there will be a orange appearance of our atmosphere. You might have seen specifically during sunrise and sunset. It is because of the scattering. It is because of the scattering. It is because of the absorption, and it is because of the reflection which is being facilitated by these particles. Suppose we have a earth like this, and we have air, and in air we have gases. Apart from the gases, we have what? We have water vapor. Apart from the gases, we have what? Water vapor. Apart from the water vapor, we have what? Apart from the water vapor, we have what? These particles or these aerosols. And suppose the sun is about to rise, so the insolation which is there, so that will going to interact, and as a result of this, the would be color would be red or orange. I mean, there might be different shades, but majoritarily you will see there that there is a red and orange colors. And these solid particles which are there, or particulates or aerosols which are there, they actually act like a hygroscopic nuclei. They act as a hygroscopic nuclei for condensation. See, whenever there is a water vapor in atmosphere, that water vapor will require cool surfaces. So that on that, while attaching to those cool surfaces, the water vapor will transform its nature in terms of water droplets. The process of condensation will going to take place when the water vapor must require surfaces. If the surfaces are there, then only this transformation would be there. You might have seen that if you put some cold water bottle, and if you put that if you put out that so sorry if you put out a cold water bottle from your refrigerator, or let's say you might have bought the same, and if you put that bottle in open atmosphere, in humid atmosphere, especially in South India, you will see that there are small droplets on the outer surface of the bottle. Now that is what the condensation, that the because of the heating because of that, in atmosphere you have a water vapor, but that water vapor which is there in atmosphere, now that water vapor is not finding cool surfaces. If the cool surfaces are there, then this water vapor will going to settle the water vapor will going to settle, and its condensation will going to take place. For that reason, water vapor require what? Condensation surfaces. So here in this case, when we have aerosols or these solid particles suspended in atmosphere, when with those particles water vapor interact, they are the cool one. And when the water vapor will going to attached, I mean water vapor, if it will be there, if it will going to attach, its status or its state will going to change in terms of water droplets, same as I told you with respect to that bottle. Okay, now don't confuse with respect to that dew drops which are there on the grasses. That's a different climatic aspect. You'll have a clarity on that. Okay, so when there is a water vapor in atmosphere, in order to get transformation in its nature, let's say from gases to water droplets, they must need what? They must need cool surfaces. So these particles or these aerosols which are suspended in atmosphere, they act as the condensation surfaces, and those condensation surfaces are being known as what? Hygroscopic nuclei. And these hygroscopic nuclei, they led to the formation of cloud droplets, and yes, they are also playing a significant role in precipitation. They are also playing role with respect to the precipitation. Here you can see this is the bottle and this is the droplets of water which has been formed. Why? Because they have attached to these cool surfaces, and water vapor gaseous state has been changed in terms of water droplets liquid. Clear? Moving ahead, here you will see that we have a gases, and yes, here you will see aerosols. So we have a particulate matter 10, particulate matter 2.5, particulate matter 1. This categorization is based on the particle size. Then we have a black carbon, sulfate, organic carbon, nitrates, and mineral dust, which could be suspended because of the mining activities. So we have these solid particles, and they act like a hygroscopic nuclei, which facilitate what? Which facilitate the process of condensation overall. Moving ahead, so this is the one of the visual of atmosphere, and here you can see we have a different layers. The reason for these different layers is what? The different density which is there, and in order to mark those different densities we have these layers. And yes, with respect to their different characteristics, features, processes, their functions, we have these categorization of our air in these layers or in these specific aspect. So the top surface layer which is near to the earth surface, that is being called as troposphere. Above it we have a stratosphere, above it we have a mesosphere, then we have a thermosphere, and the topmost is exosphere. With respect to the mesosphere, with respect to the thermosphere, with respect to the exosphere, with respect to the mesosphere, with respect to the thermosphere, we have what? We have a one specific layer of charged particle, and that specific layer of charged particles is being known as ionosphere. That specific layer of particles is being known as what? Ionosphere. Okay. So based on the based on the behavior based on the behavior, what we can say, based on the behavior of gases, based on the behavior of pattern in atmosphere, what we can say composition of atmosphere. In homosphere means throughout the atmospheric layers we have same characteristics, and we have a heterosphere means the characteristics are different when you move from one layer to another layer. So first of all, what we can say what we can say, that with respect to these layers, these air layers which are here we have a gases, and yes, we have a water vapor, we have a aerosols, particulate matter in these layers specifically. Though the proportion or the concentration could vary significantly, that could vary, and that used to vary. Majority of the water vapor is concentrated in the troposphere itself. Okay, and the troposphere is responsible for the majority of the cloud activities, rainfall, cyclone, all of them used to take place in the troposphere itself. And there is a one more pattern which you can say, that based on the nature, based on the gases, based on the nature of these gases with respect to the temperature pattern, we can say some sort of heterogeneous atmosphere or homogeneous atmosphere. So in order to learn this temperature behavior, first you have to pay attention on a very important concept, and that important concept is that That important concept is, see, this is the surface, this is the air which is having a more density. Then after a certain height, the air which is here, it will have a less some sort of density. The air which is here, it will have a more volume as compared to the other layers. So if you move vertically from this surface, so what will happen? There will be a drop in temperature. There will be drop in temperature. And this drop in temperature is called as what? Lapse rate. This drop in temperature is called as what? Lapse rate. What is the lapse rate? Lapse rate is 6.5 degree Celsius per kilometer. Means in atmosphere, if you travel vertically and if you travel by 1 kilometer, so the temperature at that point would be less than the surfaces of, or with that temperature will be less than the earth's surface, and that will be less by 6.5 degrees Celsius. Suppose the temperature on the surface is 20 degree, so after a 1 kilometer the temperature would be, just for example I am telling you, the temperature would be 14 degrees Celsius, just for reference. Okay. And yes, if you travel further 1 kilometer, successive 1 kilometer, if it is there, so yes, the temperature fall will be there. Remember, this pattern is there throughout the atmosphere. The lapse rate is throughout the atmosphere. It's because, see, it's because suppose we have a sunlight, or suppose we have a these air particles which are dense. Now they can hold temperature, and yes, here if the volume is increased, so there will be a more area for the temperature to spread. So with respect to the area, here the temperature will be less, and here the temperature will be comparatively greater. So what we can say, the temperature is greater here and temperature is less here. So we have this pattern based on the layers of atmosphere, and this pattern is being called as what? Lapse rate. This lapse rate pattern is based on the volume of air, I would say. And if the volume is more, the air will cool. If the volume is less, the air will warm. Why? Because the air is contracted. So with respect to this pattern, it is being called as what? Lapse rate. And based on the lapse rate, we also have